Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good evening to all of you. So today we continue on our lecture, chapter 4, which is a complex number. Okay. For today lecture, we are cover supposedly 3 subtopic. Okay. The first one, a complex number and properties, polar coordinates, and polar form of complex number. Let's proceed to the first one, overview of complex number. Learning objective of this subject, of this chapter. Supposedly, at the end of this chapter, you should be able to identify and understand the properties of complex number, find the polar and exponential forms of complex number, and the last one, solve complex number using De Moivre theorem. So you have these 3 subtopic for this chapter. Okay, let's proceed to the first one, introductions. In order to understand where complex number are coming from by considering on finding the roots of quadratic, okay, we can have 3 situations, okay, in order to solve quadratic equation. The first one, for the case 1, if let's say you have 2x squared plus 3x minus 5 equal to 0. So this one, you can factorize directly. And then you can get x equal to negative 2.5 and 1. This one for case 1 when you have exactly 2 roots. Okay. The case 2, you have 1 root or repeated root. Means that when you solve this factorization for this equation, you have exactly x equal to 1.5. And then the last one, no real roots. For example, when you want to solve x squared plus 1 equal to 0. And then when you want to solve this one, it is become x squared equal to negative 1. And then square root, you can get negative 1. Square root negative 1, we cannot solve it. Okay, so this one, if you solve square root negative 1, you can get plus minus I. So these situations for the case 3, we can get the answer in terms of complex number. Okay, that's why complex number come from lah. Okay, when you want to solve and then your equation in terms of a square root negative. Okay, so awak akan dapat dalam bentuk complex number. Okay, complex number stand from A plus BI. Biasanya kita guna macam ni lah, A plus BI, where A and B is the real number. Okay, and then A is called the real part, and then B is called the imaginary part. Okay, the value that stay with the I, okay, when you have A plus BI, okay, this A is the real part and this B is the imaginary part. Okay, this form is known as Cartesian complex number or algebraic forms, and also can be represented as rectangular form. Okay, if you want to find complex number in terms of rectangular form, bentuk dia macam ni lah, A plus BI. Okay, because somehow complex number we can represent by polar form or exponential form. Okay, it depend on the question lah. Kalau awak nak dalam rectangular form ataupun Cartesian complex number, dia adalah dalam sebutan A plus BI. Okay, this one as an introduction lah. For example, state the real and imaginary part of the following complex number. If you have A negative 1 plus I, so the real part is negative 1 and then the imaginary part is 1. It is state from I here lah. Okay, B, 4 minus 7I. So 4 is the real part and negative 7 is imaginary part. Imaginary part the value that stay with the I ni. Yang duduk dekat I tu adalah imaginary part. Okay. And 25I. So 25I, the real part is 0 and then the imaginary part is 25. So you need to identify lah which one is real part, which one is imaginary part. Okay. Okay, example 2. Express the following square roots in terms of I. So we know that when you have the square root in terms of negative value, okay, so we can express this in terms of I. So we know that square root negative 1 equal to I. Okay, so this one you need to transform to the square root negative 1. So when you transform, you can get square root 16 times by square root negative 1. Okay, and then square root 16 equal to 4. Square root negative 1 equal to I. So your answer is 4I. Okay, also the same thing. Square root negative 0.25. Also the same thing. You need to transform in terms of square root 0.25 times by square root negative 1. Okay, so we know that square root negative 1 equal to I. So square root 0.25 equal to 0.5. So you can get 0.5 I. Okay, this one for example 2. Okay, next. Complex number and properties. So look for the first one, forms of complex number. Okay, complex number can be represented in 3 different forms. Okay, so bila awak nak when we talk about complex number, it can be represented by 3 different forms. The first one is rectangular form. Macam kita cakap tadi lah, A plus BI. The second one is polar form. R times by cos theta plus sin I theta. And then the last one is exponential form. Exponential, you have R times by exponent I theta.
Boleh saya. Ikut saya.
So, you have a 3 form. Okay, the first one, rectangular form. Rectangular form in terms of A plus BI. And then polar form, R times by cos theta plus sin theta I. So, in the polar form, you need to know what is R, what is theta. So, how to find R, how to find theta, we will learn after this. Okay, also a same thing. When the question one asks you to find in terms of exponential form, so it is can give in terms of R times by exponent theta I. So what is R? What is theta? Nanti kita akan belajar. Okay? So it is depend on the question. Awak jangan silap bagi. If the question asks you to give the answer in terms of rectangular form, you must give answer in terms of rectangular form. If the answer in terms of polar form, you must give in terms of polar form. Also a same thing for exponential form. And then again, when we talk about complex number, you should know the quadrant. Okay? Okay, because A and B represent the quadrant. Because at theta here is the angle. If the value at the third quadrant, you kena bagi angle at the third quadrant lah. If the value at the second quadrant, you must give the angle for the second quadrant. Okay, because this theta is the angle. So you need to understand. Okay? Okay, in order to find the complex number, you need to remember back law of index. Okay, law of index, this one as a revision, when you have A, the power of 0, you can get 1. Any number the power of 0, you can get 1 except 0. Means that 0 the power of 0 tak boleh lah, not equal to 1. Okay, and then A the power of negative m also equal to 1 over A over m. Okay, 1 over a the power of m. Okay, if you have a the power of m times by a the power of n equal to a m plus n. Okay, and then if you have divide, it is become minus here. It's a power, it's a times. Okay, if your power is fractions, it's become square root, something like this. So make sure you need to understand law of index because you will use in order to find the I. Okay. For example, if you have I the power of 44. Okay. So you need to simplify first. What is the value of I the power of 44? So we will use this law. Okay. Okay. For example, power of I. So looks on the table. If you have I the power of 0, so you can get 1. Okay. I the power of 1, you can get I. Okay. I the power of 2. Okay. Because we know that set negative 1 equal to I. So this one, kita simplify ni. Awak akan apply benda ni. Okay. So I the power of 2 means that come from set negative 1 times by set negative 1 equal to negative 1. Okay. And then I the power of 3, negative I the power of 4, 1. Okay. So this table you need to understand how to get this one because we want to simplify the power of I ni. Okay, bila awak boleh simplify the power of I, so you can solve the complex number lah. Okay. Maybe we can look on the example. Simplify the following expression. Let's say you have I the power of 20. So you need to simplify this one first. You can get I the power of 4 times 5. Because 4 times 5 is 20. Okay, we know that I the power of 4 equal to 1 from the previous table. So 1 the power of 5 equal to 1. Okay. And then I the power of 10. I the power of 10 we can simplify by I the power of 8 times by I the power of I the power of 2. Yang ni. Because 8, this one times 8 plus 2 equal to 10. Okay. So we know that I the power of 8 you can simplify as I the power of 4 times by 2 times by I the power of 2 yang ni. Okay. We know that I the power of 4 equal to 1. 1 the power of 2 also equal to 1. I square equal to negative 1. Negative 1 times by 1 equal to negative 1. Okay. This one you need to understand how to simplify the power of I. So this one for example 3. Okay. Now looks on the operations of complex number. There are some properties of complex number. Okay, so looks this table. Equality. Okay, if you have a plus bi equal to c plus di, okay, means that a also equal to c and b equal to d. Additions, if you want to solve the addition, make sure the imaginary part must be solved with the imaginary part only. And then the real part must be solved with the real part. Okay, A mesti dengan C because that one is real part. Plus, I duduk kat luar. B plus D. Okay, this one for real part. Also a same thing for subtraction. The real part must be solved with the real part. So in this case, A minus C plus, and then the imaginary part solved with the imaginary part. B here minus D. So that's why we get B minus D and I lah because this one is the imaginary part. Okay, for the product darab je macam biasa. So A times C A times D, and then B times C, B times D. Okay, when BI times DI equal to BDI square. That's why when you solve BD ni, BDI square ni, you akan dapat negative this one. Okay. Okay, also a same thing for quotient. Okay, for quotient, usually when you want to solve the quotient, we times by the conjugate of denominator. Okay, what is the conjugate of denominator? So denominator you adalah A plus BI. So their conjugate is A minus BI. Okay, so expand je macam biasa. Okay, this one also same thing, expand. And then you can get this equation. Okay, boleh? Any problems? Okay, conjugate is the negations of the complex number, the conjugate. Okay, for example, okay, conjugate. Okay, conjugate, let's say you have Z equal to A plus BI. So Z conjugate equal to A minus BI. The imaginary part will be negation. Okay. Kalau daripada positif, it is become negative. If negative, so become positive. Okay. Negation of the imaginary value. That one we call it as conjugate. Okay. Product you expand. You expand this one Okay. You expand je. Okay, nanti kita akan tengok example. So awak boleh nampak kot. Lagi senang nampak. Okay. The product of complex number and its conjugate is a non-negative real number. Okay. Let's say product between complex number and its conjugate. Kalau awak ada complex number times by its conjugate, it is become real number. Okay. So it is become A square plus B square. For example, if you have 1 plus 3i and times by its conjugate 1 minus 3i. So if you expand this one, 1 times 1 equal to 1. 1 times negative 3i. It is become negative 3i. Plus this one plus 3i and then times this one. It is become negative 9i square. Okay. It is become negative 9i square here, right? Okay, because 3i times by negative 3i, it is become negative 9i square. So if you solve this one, negative 3i plus 3i, 0. So you can get 1 minus 9i square. We know that I square is equal to negative 1 because we have square root negative 1 equal to I. So I square equal to negative 1. So it's become 1 minus 9 times by negative 1. That's one you can get 1 plus 9. So equal to 10. That's why the equation is A square plus B square. A is 1 and B is 9. Okay? B square is 9. Boleh faham? This one is product with the conjugate. Okay? Okay. And then this one, to express the reciprocal of a non-zero complex number or the quotients of the complex number in the standard form, multiply the numerator and denominator by the conjugate of denominator. If you have 1 divided by A plus BI, you cannot give the answer in terms of this form. You must simplify and give the answer in terms of A plus BI. The complex number cannot place at the denominator. So how you want to simplify this one? By times the conjugate. So we know that conjugate A plus BI equal to A minus BI. Because this one is plus, so it's become minus. Kalau kat sini minus, sini become plus. That one we call it as conjugate. If you times the denominator with A minus BI, the numerator also must times by A minus BI. Dia mesti kena sama ni. Baru value dia akan sama. Okay? So solve it, you can get this one. Okay. Boleh? Okay, now look on the example. If Z1 equal to 2 plus I and Z2 equal to 1 minus I, find Z1 plus 2Z2. Okay, so this one you must times by 2Z2. We can get Z1, 2 plus I, plus 2 times Z2 is 2 here. Z2, 1 minus I. So, before you got this one, you can simplify this one first. You can get 2 plus I plus 2 minus 2I. Okay. The imaginary part with the imaginary part, the real part with the real part. So, the real part is 2 and 2. That's why we put here 2 plus 2. And then the imaginary part, I, which is 1 here. So we take 1 and then negative 2. So 1 minus 2. So you can get 4 minus I. Okay? Or if you don't want to solve. Okay, next. Z1 times by Z2. So also the same thing. Z1 times by Z2. So this one you need to expand first. Okay, Z1 is 2 plus I. Z2 is I minus I. So 2 times 1, you can get 2. 2 by times by negative I, you can get negative 2I. Next, I times 1, you can get plus I. And then plus I times by negative I. So you can get negative I square. Okay, so we know that negative, we know that the I square also equal to negative 1. Okay, I square. Okay, because this one come from square root of negative 1 equal to I. So square of I square equal to negative 1. So you need to memorize this one. So negative 1. So from here, we can get 2 minus 2I plus I minus negative 1. Okay, so minus minus negative 1, you can get plus 1. Plus 1 plus 3, you can get 3. 2I, negative 2I plus 1, you can get negative I. So this is the final answer. Okay? Boleh?
Okay.
Yeah. Okay, now looks on the example 5. Simplify the following operation. Okay, concept of complex number, when you want to solve it, you must split the imaginary part with the imaginary part. Collect all the imaginary part, put at the one place, and then collect all the real part, put at the one place. Also same thing for this one. Okay, because it is combination of 3 complex numbers. So you need to collect first. What is imaginary value? What is real value? So this one, 5, you open the bracket. 5I minus 1 plus I minus 3 minus 8I. So, which part is the imaginary? Negative 1 and negative 3. That's why I put here negative 1 and negative 3. What is the real imaginary part? 5I and negative 8I. So, this value. Solve. negative 1 times by negative 3. You can get negative 4. 5 plus 1. 6 minus 8, negative 2. That's why we put here as negative 2i. Okay. Next, looks on question B. Also a same thing. When you have these two value, you want to solve additions between two complex number. So again, we combine the real part with the real part, which is 2 and 2. So we get here 2 plus 2. Real part 7 and 5. So 7i and 5i. So it is become 4 plus 12i. Okay. Next, example 6. Okay. Given t equal to 11i, u equal to 11 minus 10i. Determine t divided by u. So we know that when t divided by u, you can get this one. So you cannot put your final answer in terms of this form. Awak mesti kena bagi dalam jawapan A plus BI. The imaginary part cannot place at the denominator. Tak boleh. So you need to solve it. How to solve? In order to solve, you must times by conjugate. What is conjugate for 11 minus 10i? Dia punya conjugate adalah 11 plus 10i. Ni. Bukan ni je. Okay. So this one, you can get this value. Times by conjugate. Okay. Your upper and lower. Okay. Nominator and denominator. Times by conjugate. And then we know that when you times by conjugate, terus awak akan dapat apa? 11 square plus 10 square. Yang kat bawah, bukan kat atas. Okay. So it is become 11 square plus 10 square. Automatically, you can get this one. Kalau awak expand pun, you must get this one also. Okay, because it is times by conjugate. Okay, bila value to times by conjugate, we can get your final answer in terms of real part. Okay, imaginary part tak ada lagi. Okay, so the above value 11i times by 11 plus 10i. So you can solve this one. You can get 121. Yes, correct. When you have the fraction, you must times by conjugate. Conjugate yang awak pilih tu mesti duduk kat bawah, bukan kat atas. Sebab kita nak solve fraction tu. Okay, so when you solve this one, you can get negative 110 divided by over 1 to 1 plus 1 to 1 divided by 2 to 1i. So this is the final answer. Okay? Understand? Okay. Okay. Make sure make a correction for this one is 2 to 1, not 1 to 1. 2 to 1. Okay. Next. Complex plane on Argand diagram. Okay. What is a complex plane on the Argand diagram? So this one you want to draw. Okay. An Argand diagrams, the horizontal axis define the real part. Okay. Means that the horizontal is the real part. Kalau real part, if you have A plus BI, means that on the horizontal is the value of A. And then the vertical axis depend for imaginary part. So means that here is B. Okay. This plane represented by the Argand diagram. If the question asks you to draw the Argand diagram, you must draw this one lah. Okay. Okay, something like this. Real part, imaginary part. A, B. So if you have A plus B, so your complex number is here. So something like this lah. You punya drawing. Okay. Okay, looks on the example. Plot the complex number A equal to 2 plus 2i, B equal to 2 minus 2i, and then C equal to negative 3 plus 2i, D equal to 8i and E equal to -4 minus 2i and 5, F equal to 5. Okay, when you want to draw, dia akan dapat macam ni. Okay, whereby A goes to 2 and then up to 2. Tu sini A. Also same thing for B because the imaginary part is negative. Imaginary part is a vertical. So dia akan turun ke bawah. Okay. And then C, the real part is negative. So dia akan pergi ke arah sini lah. Okay. And then D, also same thing. Your real part is 0. So you only have imaginary part positive. So goes upstairs. E, both are negative. So it is places at the fourth quadrant. And then F only exists the real part. So you have this value. So this one if you want to draw. Okay. Okay, next. Polar coordinates. Okay, what is polar coordinate? Okay, polar coordinate also same thing. You want to change the complex number from the rectangular form. We know that rectangular form in terms of z equal to x plus iy or z equal to a plus bi lah. It depends on the question lah. Now you want to change in terms of polar form, okay, from the rectangular form. So we know that rectangular forms, it is involved in terms of A and B. But polar forms, it's involved in terms of R and theta. So you need to find what is R, what is theta. Okay. So R represented by radial coordinate, theta represented by the angular coordinate. Okay. And then we can solve by using this equation. We know that A equal to R cos theta, B equal to R sin theta. Okay. So when we modify this equation, we can get the value of R and the value of theta when you have A and B. So simplify this one by using theorem Pythagoras. You can get the value of R equal to square root A square plus B square. And then theta we can get by tangent inverse B over A. Okay. So you need to remember B is the imaginary value and A is the real value, real part punya. Okay. Awak jangan terconfuse pula. Okay. Yang ni tak apa sebab dia A square plus B square doesn't matter. Okay. Because this one is the imaginary part divided by a real part. Okay. So we can get what is the value of R, what is the value of theta. Okay. Polar form of complex number. Okay. So how to find polar form of complex number? Okay, polar form of complex number. Okay, if you have complex number z equal to a plus bi, can also be represented by its distance r, okay, and then angle theta is something like that I already mentioned before, whereby you can be express the polar form equal to z r times by cos theta sin theta I. So in this case, you need to find r. R equal to square root of a square plus b square, and then theta here equal to tangent inverse b over a. So you can give the answer of polar form. Okay. This one. And then R is called the magnitude or modulus, combinated by modulus Z. Okay, sometimes we call it as magnitude, sometimes we call it as modulus. And theta is called as argument. Okay, for example, if you want to find the argument of Z. So automatically you need to understand the argument of Z is also equal to theta, which is a tangent inverse B over A. If the question asks you to find the magnitude, means that you want to find the value of R. So automatically awak kena tahulah. Now, look on the example. Express the following complex number in polar form. Maksudnya awak nak cari in the polar form. Complex number. So yang ni just only have 5. The imaginary part, we don't have it. Okay. So, we need to find what is R, what is theta. Okay. We know that 5 ni, if you draw the Argand diagram, dia akan duduk straight ni. 5. Okay, means that the angle theta is 0. 10. And then the R, if you want to find, we know that R equal to square root of A square plus B square. Okay, and then A is 5 square. B is 0 square. So 5 square equal to square root 25. Square root 25 also equal to 5. And then angle theta equal to 0 degree. So when you want to solve it, awak akan dapat macam ni lah. In the polar form. 5 times by cos 0 degree plus sine 0 degree I. Okay. In terms of polar form. Okay. Next. This one. Express the following complex number in the polar form. Also a same thing. In the polar form, the key idea, you need to find what is R first. R, we know that square root of A square plus B square. So, what is your A? A equal to 4 square plus what is your B? Negative 4. Negative 4 square. So, this one you can get 16 plus 16. So, equal to 32. So, when you solve this one, 32 also equal to 4 2. If you give this answer also correct, if you give the answer also correct lah, doesn't matter, you can choose either one lah. And then we can find the theta. Theta equal to tangent inverse negative 4 over 4. Okay. This one, you need to remember this 4 minus 4i places in the which quadrant? Ni. Dia akan duduk dekat kuadran keempat. Fourth quadrant. Because your value of real part is positive. Akan pergi ke arah positif. And then the value of imaginary part is negative. So it places at the fourth quadrant. Because when you want to calculate your calculator, if you press your calculator, tangent inverse negative 1. Kan? Okay, tangent inverse negative 1, you can get negative 45 degree. So, you need to know where is negative 45 degree. Negative 45 degree, it is places at the fourth quadrant. You must refer to the first question. Awak kena tengok dulu ni. Question you, it is places at which quadrant? Okay. So, you can get this one. Negative 45. Okay, you can give the answer something like this. Or if you don't want to give in terms of negative, we know that negative 45 also equal to negative and also equal to 315. You can choose either one lah. Okay. If you want to give the answer in terms of degree, doesn't matter. Okay, but you also can give the answer in terms of radian. Okay. Boleh? Mana dah? Okay, you can choose either one, whether you want to write as this long or this short as cheese. Okay. Yes. Makan je kerja awak ni. Okay? Doesn't matter. Actually, cheese is the short form from cos, sin and I. Ni cos, sin, I. So dia ambil jadi cheese. Okay. That one for example 2. Okay. Now looks on the example 2 also B. Ni this number B. Okay. Z bar. Also same thing. If you have this 4 plus 4i. Okay. You want to transform in terms of polar form. So first check which quadrant. Positive, positive. So it places at the first quadrant. Kalau dia duduk kat first quadrant, tak ada masalah. So first you find R. R equal to square root of 4 square plus 4 square equal to 32. Also equal to 4 2. Okay. And then theta. Theta equal to tangent inverse 4 over 4. So you can get 45 degree. So your final answer is 4 2 cheese. 45 degree. Okay?
Okay.
Boleh? Okay. So, or you can put something like this lah.
Kalau sin tu macam mana? Sis.
Ada. Next. Find the rectangular coordinate of the point B. So, ni dia bagi. Find the rectangular coordinate of point B was polar coordinate. Okay, it is given in terms of polar coordinate. So, you want to find rectangular coordinate. You need to understand what is rectangular coordinate. Rectangular coordinate means that coordinate in terms of A and B. Ni, A plus BI. This one is rectangular. So you need to find what is A, what is B. We know that A equal to what? A equal to
2.
R cos theta. B equal to R sin theta. Gitu. Mana boleh? Sebab question given to you in terms of polar coordinate. Okay, so you can find R equal to 2, theta equal to pi over 3. So put in the equation, A equal to R cos theta. R is 2, cos theta cos pi over 3. Make sure pi over 3 in radian. If you want to use your calculator, make sure change to radian. Kalau awak nak guna calculator in degree, change to degree. Pi over 3 means that 60 degree. So when you press a calculator, you can get 1. This one for A. For B, R sin theta equal to 2 sin pi over 3. Also is same thing, sin 60. So you can get 3. So your final answer, your rectangular coordinate. Ingat coordinate. Coordinate means that point. So mesti awak kena bagi dalam bentuk bracket. Bukan rectangular form. Kalau rectangular form, you must give your answer in terms of form. Macam ni. Ni rectangular form. Kalau koordinat, awak kena bagi dalam bentuk bracket. Macam ni. Jangan salah. You need to identify. Okay. Koordinat or form. Kalau form, you must give A plus BI. So it is become 1 plus 3I. So this one is rectangular form. Question ask you rectangular coordinate. So coordinate awak kena bagi dalam bentuk koordinat lah. Which is point. Okay. Okay. Example 4. Find polar coordinate. Coordinate. For the point, rectangular coordinate. Okay. Ni dia nak dalam bentuk polar. But coordinate. Coordinate means that point. So when you want to transform the rectangular to the polar, so you need to find what is theta, what is R. Because you are given A equal to -3, B equal to 7. Okay, so we know that R equal to square root of A square plus B square. Masuk gitu je. And then theta equal to tangent inverse P over A. So when you solve these two, you can get R equal to what and theta equal to what. Okay. So R equal to 4, theta equal to 138.59. Remember, when you calculate this one, you can get negative 41.41. Again, you must check which quadrant. This one places at the second quadrant. Okay, so you must give the angle at the second quadrant. Angle at the second quadrant, 180 minus 41.41 because 41.41 is here. Jangan salah. Okay. So, give in terms of coordinate, you can get for this one lah. Okay. Any problems? Okay. If you don't have
sir.
problem, thank you. That's
Sir.
all for today.
Sir,